8 2024 question 23. Consider the control structure for the overhead section of the distillation column. Let us quickly understand what are the components here. This of course is my pressure controller. This is a level controller which controls the level in the condensate drum, and this is the composition controller which measures the composition of the heavy key. So of course again is the flow control. And this is air to close, means more airflow will close the valve, control valve here, and this is air to open, and this is air to close. Very quickly, let us see if this control logic is correct or not before we go to the actual question, and that is the controller gain. If there is a loss of flow, airflow to this control valve, of course, what it will do, it will air to close. So if there's no flow of air, this will be completely open. Therefore, the maximum flow of coolant water will go to this one, which will of course reduce the pressure, and it is more safe to operate the distillation column that way. Here, it's also the same thing. If there is a loss of air to this particular control valve, therefore, what will happen? This air to close. So, therefore, if there is a loss of air, this will be completely open. So, maximum the condensate which comes in, which will go back to the column as reflux, which is also a safe condition for operating the column. Now, let us look at the actual problem, that what will be the sign of the controller gain. Let us say if the pressure increases, first let's look into this pressure controller here. If the pressure increases, we know the relative volatility of course decreases. That means the heavy key concentration in the overhead paper increases. So therefore, of course, naturally the temperature will increase. And what we want to do, that of course we'd like to reduce the pressure, right? That would be our goal. So how does it happen? That as the pressure increases, of course, we know the error, which is normally the set point minus the measured value of the process variable. If that becomes negative, so what will happen if this is a positive gain? So there will be a negative effect here, which means that it will open, this valve will open and allow the more flow of water, coolant air through this particular heat exchanger. So therefore, what will happen? More of the vapor will condense, and of course the pressure will decrease, which is of course desirable. Let's look at this composition controller, where of course we have this ratio block and the sigma node right here. So this measures the composition of the heavy key. As the impurity in the distillate increases, if the impurity in the distillate, that means the heavy key increases, what will happen is that it will it will send a signal to this summation here, so it will adjust the set point. So if we increase the set point, what will happen? If increase the set point, what will happen? The error will decrease, and correspondingly, what will happen? There will be of less flow of air to this particular control valve right here, which will allow more reflux going back to the column. And correspondingly, as more reflux goes back to the column, what will happen? The concentration of the heavy key in the distillate product will decrease, right? So that again is desirable. So of course, this one we want as a positive one, and this one of course we need as a negative gain. So the answer D, that means positive gain for the pressure controller and the negative gain for the composition controller is desired. So D is the correct.